In our last example, we learned how to calculate a z-score for a data value. So what we're really doing when we're doing that is we're finding a corresponding value on what's called a standard normal distribution. And that is a normal distribution where your mean is at 0 and your standard deviation is at 1. This does not mean that the data you're analyzing has a mean of 0. We are kind of forcing the mean is 0. Standard deviation, whatever it is, we consider it 1 unit. So here is a standard normal distribution. And if you think about it, everything that's in here is 100% of your data. This also means if we look at it as area, total, I don't know why I started to write take, total area is 1. And your z-scores are the corresponding value. So anything that you calculate, you're getting numbers in here that kind of tell you how many standard deviations you are above or below the mean. So now we can break this down into percentiles. And a percentile is the percentage of values less than or equal to a particular data value. It is equal to the percentage of the total area under the distribution curve for the population to the left of that value. We're going to take a look at some examples here. So some of these are easy. If you'd be right at the mean, you'd be in 50% of your data. If you'd be, say, right here at 1, and again from the left here, 68%. But as you could see in our previous example, we got z-scores of like 1.9, 2.2. Those are not z-scores that we can automatically get a nice, good percentage. So what we are going to start doing is using z-charts. Let's take a look at an example. Let me read you a work problem from the book. The weight of a captive adult female lowland gorillas is normally distributed with a mean of 82.30 kilograms and a standard deviation of 15.33 kilograms. Calculate a z-score for Sasha. How can you use this score to find the percentage of captive adult female lowland gorillas whose weights are less than or equal to Sasha's? And you're missing the graphic of Sasha. Sasha is a female lowland gorilla and she weighs 61.8 kilograms. So let's go ahead. This is the information we were given. Let's go ahead and calculate her z-score. So if you remember, z-score is your data value minus the mean divided by standard deviation. So her data value, her weight, is 61.8 minus the mean of 82.30 divided by the standard deviation of 15.33. And when you plug that into a calculator, we're going to round it to the nearest hundredths. You get a negative 1.34. So we can already see from this value it's negative. That means, let me scoop this down, her data value is somewhere right in here. We are less than 1 standard deviation, excuse me, we're more than 1 standard deviation below the mean. So we're right there. So let's go ahead, and this is the point you might want to make yourself a note. This is where you're going to look at the z-score table. That's not a nice even number. It's not a -1 and -2 that we could easily take a look and determine the percentage. So here we go. This looks a little overwhelming at first. Here's my side. You've got 2 pages here. And now these are all your positive z-scores. I want the negative ones. I'm at a negative 1.34. So what I'm going to do, negative 1.3. Okay, right here. Here's a negative 1.3. Okay, so now I want my hundredths, negative 1.3. And if I look up here, there it is, 0.4. So what you're going to do is you're going to bring it across. I'll see if I can keep this on the screen. So if you look, this is the 0.00 column, 0.01, 0.02, 0.03, 0.04. So it is right here. So this is what I'm looking at. This is the percentage. Now, if we round that, and again, don't forget, we're decimal. If you go decimal to percent, 1, 2, move that decimal 2 places over. I'm at 9%. So let's see, Sasha's weight, 9%. So this means, now let's summarize this. This means that about 9% of all captive adult female lowland gorillas have a weight less than 61.8 kilograms. Let's jot that down. That's a lot. So about 9% of all captive adult female lowland gorillas have a weight less than or equal to Sasha's weight, which is 61.8 kilograms. And now your try it. Let's just write it in here. Your try it, number 4. Find the percentage of all values in a normal distribution with z less than or equal to 1.85. So let's just make a note. We are looking for z scores less than or equal to 1.85. Okay, so what I'm going to do, I'm going to grab my z-score table. 1.85, so that's positive, so I'm on the positive side. I'm going to look for 1.8, and here it is. And my hundredths unit was 5. So, and again, if you look up here, you can see, and then you can just bring it down. My eyes don't always like to follow that. So right here. 0.96784, I'm going to move that 2 places, the decimal 2 places to the right, 1, 2. And I'm going to round, that's going to be 96 point, if I look, let's do it to the nearest 10th, 96.8%. So that is, again, that is going to the left of this z-score. This z-score is almost up to 2 standard deviations above the mean, not quite, but this means that 96.8% of the data values are to the left of this z-score, to the left of 1.85 standard deviations above the mean.